In today's lesson, we are going to review our exponent rules as well as look at a little bit of fractions. We're going to be kind of introducing these topics or reviewing these topics as an introduction to our rational expressions or rational functions unit. So just want to review a little bit of fractions, right? So again, adding and subtracting fractions, make sure we have a common denominator. So when we add and subtract fractions, we need to have a common denominator. So in the first one, 1 over 2 plus 1 over 8, I need a common denominator. I can actually get one by multiplying both sides, both parts of my fraction by 4, which will give me then 4 over, me 4 over 8, which is equivalent to 1/2, plus 1 over 8. And now I can add my fractions together, right? I don't change anything to the denominator. Right? I keep the denominator the same, and I add the numerators. So 5/8 is what this works out to. Now, in this case here, for the next one, for B, even though we have variables in our denominators, we can still get a common denominator. And similar to if we were dealing with just values, the same can apply here, where I am going to multiply both fractions by the opposite denominator. So what I mean by that, I'm going to multiply 2 by 3y, keep it consistent by multiplying the top by 3y as well. And I'm going to multiply 3y by 2, which is the other denominator, and multiply the top by 2 as well. So this would work out to, I have now 4x over 6y minus 3y squared over 6y. Now I can subtract, so I can do 4x minus 3y squared, all divided by 6y. Oops. So even though I can't actually simplify the top any further, I can't subtract those two values, I can at least combine my two fractions together in a sense. When we're multiplying and dividing fractions, we don't need to worry about common denominators, right? Multiplying fractions, we just multiply straight across. So you multiply your numerators together and you multiply your denominators together. We end up with 3 times 4 divided by 2 times 5. We get 12 over 10. 12 over 10, which we could reduce to 6 over 5. For B, when I'm dividing fractions, when I divide fractions, I want to flip the second fraction and multiply. So I'm going to flip the second fraction, so 3 over 2 multiplied by 3 over 4. So I flip the second fraction, I multiply, I end up with, I end up with 9 over 8. And I can't reduce that any further. So I flip the second fraction and I multiply. Now there are some rules that we want to kind of consider when we're dealing with fractions. The first one is we can never have a fraction with a denominator of 0. Why? Well, one, we can't divide by 0, and why is that? Well, if I say I have 6 over 2, that equals 3. And what that means is 2 times 3 equals 6, right? Or 2 groups of 3 equals 6. Now on the flip side, if I have 6 divided by 0 equal to something, which we know it doesn't, it can't, and that's because 0 times what equals 6, there isn't anything. Right? So there isn't anything that we can multiply 0 by to get to 6, right? So there is no value. So that is why we can't have a denominator of 0. We can't divide by 0. Another rule is cross multiplication of fractions only happens when there is an equal sign. So similar to basically setting up proportions. So for example, if I have 2 over 3 equal to x over 5, now I can cross multiply. Right? So 2 over 3, or 2 times 5, 3 times x. We get 10 is equal to 3x, and I can solve for x. 10 over 3. So only when there's an equal sign can we cross multiply. Right? So we shouldn't be cross multiplying in any other scenarios. We shouldn't be multiplying or cross multiplying in that matter. Third rule, we can only cancel out when multiplying factors. Right? So I can't cancel out, or I can only cancel out when we're multiplying fractions, sorry, not factors. So example, what I mean by that, if I have x plus 1 divided by x, I can cancel out the x's, and I'm left with x plus 1. I could also have, say, something like a coefficient and a variable in front, divided by, say, 4x, and I can reduce my coefficients or reduce some parts. I can reduce 6 divided by 2 is 3, 4 divided by 2 is 2. The x's would cancel out. And I'm left with 3 times x plus 3 divided by 2, which I then could expand the top if I wanted to, but I've already kind of canceled out. We cannot cancel out when adding or subtracting fractions. So what we mean by that is if I have x plus 8 divided by x, I can't just say, oh, those are gone. We can't do something like that. Same as if we had 2x plus 3 divided by 4x. I can't just simplify these and cancel those out and be left with 3 over 2. So if I'm adding, which we see happening here and here, right, or subtracting within our fractions, we can't cancel out. Now, what we could do, and we've talked about this a bit with in our radicals unit, I could technically say 2x over 4x plus 3 over 4x, simplify the 1. I could then simplify this to make it 1 over 2. So I could simplify it to be 1/2 plus 3 over 4x. I could do that, but then again, I would want to add my fractions together to simplify it, which wouldn't make this any different, right? It would bring me right back to where I started. So I could break it apart similar to like we've done in our radicals unit, and simplify individual parts there, or I can just leave it as is. So those are some rules to consider when we're dealing with fractions. Now, in terms of power rules, this is just a review of all the different kind of power rules that we've dealt with before. One, adding and subtracting monomials, right? Combine like terms or collect like terms, right? And we don't change the variables in the exponents. So for example, 3x squared y plus 2x squared y, those are like terms. They have the same letters and the same exponents. So I'm just adding the values, the coefficients. So this becomes 5x squared y. We don't change the variables or the exponents when we're collecting like terms. Now, when we get into our power laws, we will change the exponent, but we're not adding or subtracting anymore. We're going to be multiplying, dividing, or raised to an exponent. So for example, x to the power of a times x to the power of b, we add our exponents. So in this example here, I'm going to focus on like parts, similar to when we're dealing with radicals. So negative 2 times 3 is negative 6. X squared times x cubed. I'm going to add my exponents, so I get x to the power of 5. And then y times y to the power of 2. 2 plus 1 becomes 3. Keep in mind, if I don't see an exponent, I assume it's 1. Quotient rule, we subtract our exponents. So in our example, 28x to the power of 5 divided by 42x, I can focus on my numbers and divide those, or simplify them. In this case, I can divide by 14, and I get 2 over 3. I can then focus on my x's. X to the power of 5 divided by x to the power of 1, I subtract. I end up with x to the power of 4. Positive fractions usually means that the power is on top. Power of a power rule, x to the power of a times x to the power of b. I multiply my exponents. X to the power of a times b. Again, if I have multiple components and they're all raised in a bracket raised to a power, that exponent applies to everything. So negative 2 to the power of 2 is 4. Is 4x cubed to the power of 2. I multiply. 3 times 2 is 6. So this works out to 4x to the power of 6. With a negative exponent, the negative exponent rule tells us that we flip our base and the exponent becomes positive. So for our example, again, we're going to focus on like parts. 4 over 8. I can divide that or reduce that to 1 over 2. I can then focus on my fraction, or my variables. X to the power of 2 divided by x to the power of 5. I subtract. So like x to the power of negative 3. However, I want a positive exponent, so I bring it down. 1 over 2x to the power of 3. General rule of thumb, we do want to have positive exponents, or always have positive exponents. Exponent of 0, x to the power of 0, anything to the power of 0 is 1. So 87 to the power of 0 is 1. So let's look through a couple of examples where we simplify the following expressions using exponent laws. So 12k squared m to the power of 8 divided by 4k to the power of 5 m to the power of 5. I'm going to focus on parts that are similar. So I'm going to focus on my value, or my coefficients. I'm going to focus on my k's, and I'm going to focus on my m's. I'm going to focus on them individually. So 12 divided by 4 is 3. K squared divided by k to the power of 5. Dividing powers, I subtract. K to the power of negative 3. M to the power of 8 divided by m to the power of 5. Again, I'm dividing, so I subtract. M to the power of positive 3. General rule of thumb, we want positive exponents, so I need to bring that k to the power of negative 3 down, or we're going to create a fraction, we're going to bring it below, and the exponent becomes positive. And that is my simplified rational expression. For b, I have to multiply first. So again, I'm going to highlight. You don't have to highlight when you go through and do this. I'm just doing this just so you can see how we're focusing on just individual components or parts that are similar. So when we have multiple parts or multiple operations, we want to simplify both parts of our rational expression first and then divide. So simplify the numerator, simplify the denominator before we divide. So on the top, I can multiply, and on the bottom, this exponent of 2 is going to apply to everything. So on the top, I'll do that first. 5 times 4 is 20. C to the power of 3 times c to the power of 2. Power laws say we add our exponents. 3 plus 2 is 5. And for d, d to the power of 1 times d squared, we add, we get d to the power of 3. On the denominator, that exponent 2 applies to everything, so 2 squared is 4. C squared to the power of 2, we multiply, so c to the power of 4. And d to the power of 1 to the power of 2 is d to the power of 2. Now, again, now I can divide. Everything's simplified. I can divide. Again, I'm going to focus on similar parts. 20 divided by 4 is 5. C to the power of 5 divided by c to the power of 4, we subtract. So c to the power of 1. If it's to the power of 1, I don't need to actually show it. As long as I have a c there, if there's no exponent, it's assumed that it's 1. Then d to the power of 3 divided by d to the power of 2, again we subtract. We get d to the power of 1, which we don't need to show. We can just represent it as d. Another example in C, same idea. We're going to simplify the numerator. The denominator is already simplified, so I don't need to worry about that. 3 to the power of 3 is 27. X to the power of 1 to the power of 3, x to the power of 3, we're multiplying, and y to the power of 3. This is all divided by 9, x to the power of 4, y to the power of 4. So when I simplify this, I'm going to focus on similar parts. My coefficients, my exponents with x, and my exponents with y. 27 divided by 9 is 3. Dividing power, so I subtract my exponents. So 3 minus 4, x to the power of negative 1. 3 minus 4, y to the power of negative 1. Again, because we want to end up with positive exponents, I need to move my x and y down. I'm going to create a fraction and move them down. I don't need to show the exponents because they're 1. So I have 3 divided by xy. For D, again, similar concept, similar to what we've been doing. This one's very similar. This exponent is going to apply to both parts. Now, I'm not going to worry about my negative exponents until I'm done everything. Right? I want to simplify everything first. I want to go through my operations, treat them as normal, add or subtract or multiply my exponents until I'm done doing everything, and then I'm going to worry about flipping or getting positive exponents. Just because you don't want to flip it early or change the exponent early to a positive and then realize that after you multiply or subtract, oh, it's a negative again, so I got to move it back. So this negative 2 applies to both parts, so 2 to the power of negative 2, z to the power of 3 to the power of negative 2, so I multiply, I get z to the power of negative 6, divided by w5z2. I only have one thing that I really have to worry about. It is my exponents, or my powers with z. So 2 to the power of negative 2, z to the power of negative 6 divided by z to the power of 2. So I subtract, and I get z to the power of negative 8. The w5 will stay on the bottom. There's no other w on top, nothing I can combine with it. I can bring my two negative powers down. There's nothing left up on top, so I'm going to leave it as 1 for a placeholder. So I get 2 squared w5 z8. And I can simplify 2 squared to be 1 over 4 w5 z8. And that is my simplified expression. Again, one more example. Again, just more practice. This exponent applies to everything on the inside. There's nothing I can simplify on the bottom. So I get x to the power of negative 20 times x cubed divided by 3 x to the power of negative 1. Again, even though I have negatives, I'm going to simplify and do all my operations first before I worry about converting positive exponents or negative exponents to positive. So in the numerator, I multiply, I add, I get x to the power of negative 17 divided by 3x to the power of negative 1. I divide, so I get x to the power of negative 16, because minus negative 1 is the same thing as adding 1. 3 stays on the bottom. There's nothing I can simplify with that. But because I have a negative exponent, I can bring that down. So I get 1 over 3x to the power of 16. And that is my simplified form. One more example, but we're going to be looking at combining fractions and exponents. Right? So what we can do here is we can simplify our two fractions using our power laws. So I'm going to simplify these two fractions first, because I can leave the 3 over 2, x to the power of 3 divided by x to the power of 2. Right? We subtract, we end up with x to the power of 1. We're going to add on the other side. The 4 over 3 is going to stay the same. The y's can cancel out, and I'm left with y to the power of 3, because 4 minus 1. Now I can get or add these fractions by first getting a common denominator. So I have to multiply both sides by 2, because I can get a common denominator of 6. Again, when we're multiplying, right, you're going to multiply the coefficients. Oops, sorry. This first side should be multiplied by 3, not 2. I'm going to multiply the coefficients, so similar to when we're dealing with mixed radicals, coefficient times coefficient, we get 9x over 6 plus 8y cubed over 6. I can add my numerators, so 9x plus 8y cubed, all divided by 6. I can't reduce it any further. There's nothing, because I'm adding these fractions here, I can't cancel anything out. So I'm going to leave it as is. And that is my simplified form. So the big thing from today is just a review of some of the concepts that we should have been already familiar with. The dealing with power laws might be a review because you might not have covered them in a while. Fractions you probably have seen before, or you should have seen before and used before. So you should be familiar with those rules. Maybe this combination might be new, but it's the same concept, same idea. Nothing really changes. We just now have variables involved. So again, just a little bit of review before we get into kind of the newer parts of the unit.